please exclude some problems with the recording and especially also with the video on my side, as there have been some problems with the recording tool. So don't be angry that the quality is not as you usually want. You know it from the videos that we do. Thank you. Hello. Today we're going to look at something pretty cool that is not directly related to CI/CD, but that's where all CI/CD starts. It starts on your developer desk, and I am very fortunate that I have CNCF ambassador and container specialist, I think, Carlos, on the show today to talk us through Kubernetes local development.
Glad to be here. Thank you for the invitation. I'm a CNCF ambassador, contributor in around the projects of Kubernetes, and also run a CNCF community meeting. It's called the Kubernetes Book Club. On every Friday, Thursdays, we meet. You can find it on the CNCF communities, and we do virtual meetups to talk about all topics of Kubernetes and cloud native. And in AWS, I work with a lot of customers as a container specialist, solutions architect around Kubernetes for compute, and also Kubernetes as a platform to build infrastructure. Platform teams are using Kubernetes to do that. So we'll talk a little bit about that today. But today, I think we're going to talk about like how do we help developers like work with containers, and then how when they get started in Kubernetes. It'll be a good session today.
Yeah, and you're going to also teach me a lot because, yes, I work with Kubernetes and containers for a while, but I've never managed to get something up and running on my local. So that's going to be a good learning expertise for me as well.
Yep. Yeah, and the good thing is that there have been a lot of like new enhancements and new tools, and what myself and other community members have been working on an also open source project called Canoe CNOE with some of this tooling to make it super easy for people to get started and get a workflow working.
Yeah, and that's how actually we also met, looking at Canoe, and then getting myself a little bit into that topic. I found out that it's not as simple, right? So maybe let's start to set some baseline and let's talk a little bit about what the hell is a container and how do I run it locally? Maybe want to start there?
Yeah, let me show my screen because I have some notes here, and we'll go and discuss some of these things. Share.
By the way, while we're waiting, which is your favorite shoe on the background? Which is the one that you like most?
Actually, the ones that I'm wearing is the Jordan 11 bread, but the second ones are the Jordan 4s. Likewise, I have a lot of them.
Which color is that? The white ones?
The white and green are kind of like my favorite one.
Okay. I like the yellow ones from a color perspective.
Yep. Also, the black ones go with a lot of clothes. So yeah, that's a few of them. I don't have that many, but a few. So I don't have space in my closet, so I put them in the wall. So yeah,
it's a cool background.
Thanks. A lot of people are asking me if I work in a shoe store lately. So I'm not. So Star Wars and sneakers, kind of like a cool thing to do, hobby. So yeah, let's talk about containers. And what are containers? If people don't know what containers are, it's a way of like running a process in Linux, and also we also have any operating system right now these days. But in terms of like running apps in for example AWS, I work for AWS in the cloud. You have multiple ways of running an application on the cloud and using containers. So the value out of a container is just because they're cool, the latest technologies, they're portable. They're becoming a standard that a lot of software apps, desktop apps, server apps uses container images, and that's a standard of an artifact, like a file artifact that if you give a container to someone, and usually you give it by giving a registry or you put it in a repository, that person should be able to download it and then run it, and it should work out of the box. Like if it needs environment variables or files. There's a standard way of doing it. And in AWS, we have different ways. We have many ways, but the common ones that I also usually work with are like EC2. People forget, like, you can get just a VM, install Docker or Containerd, one of these runtimes, and then run one of them, and then you're up and running in minutes. And the other ones are like App Runner, a little bit of like running a container that it's basically executes on requests. Also Lambda, which is our serverless offering. You can take, maybe you're developing a web app, and usually containers, in terms of, we're talking about Kubernetes, it's APIs, web apps. You can have something like the Lambda adapter, and then take your Express app or your Flask app, and then wrap it and then put it in front of API gateway, and then it runs on the request. ECS is our Elastic Container Service. A lot of customers use it in terms of like running a task with one or multiple containers. And then Kubernetes, which is, we have Elastic Kubernetes Service, EKS. That's the service that I'm mostly more familiar with, because the customers that I work with, I'm helping with solutions are around Kubernetes, and I've been in the project in open source Kubernetes since I think about 5-6 years already. So I'm very familiar with it, and I'm trying to build tools to make it super easy for people to use it.
Maybe a tool that we would need would be how to choose the right container engine for your workload in an automated fashion, right? I think there's 2 more services as well, Lightsail and Beanstalk, that can also be used to run containers. I don't know how much investment is going into those these days, but just the amount of different services shows how complex the container topic in general is.
Yeah. Choosing one of them, and it depends on the capabilities that you're looking for. It depends on a lot of things, right? You're a solo developer, or you're in startup, or you're in an enterprise. Locally, if you're in enterprise, and I think that's what we wanted to target, like enterprise developers that they don't get to choose the runtime, right? They're like starting in a company, and they already have an onboarding process for day 0, hopefully, right? That's the type of customers I'm helping with. Like, a developer comes in, or 100 of them come in this quarter. A lot of the decision making is already made, right? They may say, hey, we are using EKS, or we are in the point of migrating a lot of Kubernetes apps that we have on premise. We cannot, that's a typical story that I hear every week, is we have Kubernetes on premise, and we don't have enough hardware. I'm not planning to buy more hardware, and we need to move these Kubernetes apps, which are just orchestrating containers. We need to move them into AWS, and we want to use EKS, because the control plane in Kubernetes, there's a control plane where, like, some servers like etcd, the database, and the API server, if you're running on premise or yourself, that's something that you have to maintain. In EKS, just like becomes an API, but you still need to work, like, your worker nodes, your EC2s nodes, or your Fargate. You need to work with that. But yeah, those decisions are made for you when you come in on. So yeah, for today we're going to Kubernetes. So let's say that you come into a company and they decided that they want to use EKS, or they've been using EKS, and they're trying to have an onboarding process. Or maybe this is something for someone that is in the IT department, right? That it's a platform team saying, like, I really need to find a workflow that I can document for the developers, for them to be as productive as possible. Shifting left, right? And shifting left is not throwing problems to the left. It's like finding errors as soon as possible, doing the testing as soon as possible, testing as in a way that looks very similar as the final place where the app is going to run in production.
Yeah, that's a lot of enterprises are using EKS, and I think it's really hard sometimes to then get into the weeds. especially as it hides a lot of the complexity that we have under the hood. And we need to understand that complexity to then be able to actually make best use of the time, right? And as you said, the more I can shift to the development laptop, the faster is the feedback loop. And that's what I've been trying to achieve as well. And being able to reproduce some of the problems that I got on a normal, on a bigger cluster, EKS cluster running somewhere, being able to reproduce that locally can be very challenging. And I believe that this stuff can help you to speed up your inner development cycle. So let's continue to set the foundation of what do we need to know in order to start working with Kubernetes from your
So
perspective,
let's talk about
Carlos?
containers, because a lot of if you know the basics, the fundamentals of like a container, I guess building a container, packaging an app in a container, and then running in a container before you get to Kubernetes, it will be very useful. You will have a very good foundation when you are in Kubernetes. A lot of the questions or troubleshooting or best practices are not Kubernetes. It's around the container, and that's where like a lot of people get mixed up of like, why do I need to have this much configuration for X? Well, half of it is a container concern that you need to do it. Doesn't matter if you're running on AppRunner or Elastic Beanstalk or ECS. And the second half is like, yes, the concern, this configuration is extra because of Kubernetes running multiple replicas of your container and running a bunch of them most efficient as efficient as possible of doing bean packing, right? Maximizing the utilization of the servers that these containers running more than one container, auto scaling nodes to fit those containers. So that's the second part of it. And a lot of those things are just Kubernetes, not even EKS, not even about AWS. We're running the open source software on your behalf, so you don't have to worry about that control plane. But the rest is the same way as you're working with Kubernetes locally, and we'll see that like if you understand how to run Kubernetes locally, that percentage of knowledge of configuration, then you can actually replicate it and troubleshoot it. And like a lot of engineers love to learn how things works, so you can do that locally in your computer. That doesn't say that you as a feature engineer, as some enterprises call it, a feature engineer, you need to spend more time on the feature that you're writing, right? Your Python program, your JavaScript program, the hundreds of APIs that your app is trying to call, and then you're trying to figure out how to authenticate to all these places. Kubernetes is just the car that gets that value in, right? And it takes it somewhere. But so it should be less important to you, more important to all the individuals in the org. So that makes sense.
It does.
So yeah, for containers, there's a file called Docker file. There's some tools that actually would detect your program, and it would either create the Docker file on the fly or create a container. So the first thing that you're going to be doing is, so for example, I have here a folder called app, and I have a Docker file. So let me move this to the side here. You tell me if the font looks okay.
I think it's still
so
good.
This
yes,
is
I can
the
read
syntax,
it good.
and there's it's a lot of I put do not disturb. Sorry for that. So let me start over. A Docker file has a syntax, and this syntax has been around since
For a long time already.
2013. So 11 years. We're dating myself. And then this year was Kubernetes 10 years. So Kubernetes is 10 years old. Docker got around 10 years. Containers were a technology in Linux even before that. So there's a lot of like help online, blog posts, a lot of information and documentation online that will help you like figure out what is the best way to create a Docker file, more effective way of running that. But just to highlight a few things on the Docker file is a base image, which becomes kind of like your runtime. So this space image is an image that is going to have the runtime. So if you have a Node.js application, in this case I have a Node.js application, the Node.js runtime from the open source program and operating system files will come from this space image. So you're basically adding your app. When you do a copy, you're just copying your JavaScript. So in here I have one index.js, I'm copying my files in there and then installing my dependencies and then running it. ChainGuard is a company that is, I have a few friends working there, but also they're a partner of AWS, and they have images online that they focus on being zero CVEs, meaning like security wise, they try to make it as small as possible, and also making sure that there any security patches, they're very patched very quickly, and also even FIPS. But you can do this, get images from other places, and potentially in your company they will have like a base image that they maintain, and it could be coming from one of the AWS base images or the ChainGuard images. But I'm just using this for today as an example. That they have multiple of them, and then they have for Node.js, they have Python.
Yes.
Let me see if I can find the Git repo. So I follow these examples. Like if I go to this repo, you can find in here. And if you're getting started, this is just if you're getting started maybe and I want to pick up an example, they have this repository here that you can go into the node, or maybe you want to do Python. Python is becoming very popular, and they will have a Docker file. But again, these are like the hello world Docker files. In your company, they made the team that is in charge of like giving you these base images or examples or templates. They will have like maybe more sophisticated like Docker files, but you can get started like quickly in your laptop with these simple examples, right?
And in order to run that, I will locally need Docker desktop, right?
Yes. So I already have a Docker file in here, like I said. And if we want to run my app, which is here, right? I can just run it in my computer. I have Node.js, and I guess I can go into this folder and then run node index.js, and my app is up and running. So I can do a curl localhost 8080, and it says hello world.
Yay.
It's literally a hello world. One of the things that also we can point out about the code before we get to package it is this is the development workflow. Like a lot of like people just like don't use containers, and you can use sometimes this is my workflow, right? I don't use containers. I just run my app, and I have environment variables that I use to configure my application. And then when it becomes a container, then those environment variables get passed to the container. But one thing that as a best practice is for certain applications that you're working in Kubernetes, by default, it assumes it's going to be a web server that it runs all the time. And if your app dies, it will restart it again. And then when it's time to like shut down your application, Kubernetes will send you a sick term signal. And that sometimes like people forget to put that handler in their applications. And that's why sometimes in Kubernetes, people say like, why it's taking so long to shut down the app or upgrade to the new version or roll out an update. So here's an example on how to do that. And also, if you're running in Docker, when you send the control C, you're sending a sick int. So that's why I have both in there. So small things that like if you don't know about them, it would like get in your way, and you don't know why. So just giving you maybe a tip. I'll keep giving tips. I don't know if that's useful.
It is.
So
I didn't know that, by the way. So that's learning for me already.
Yeah, so that's one of the things. So this is why DevOps is important, right? People throw the DevOps word around, and DevOps is about the communication between this team that knows a lot about containers and Kubernetes, and this other team that knows a lot about, like in this case, let's say Node.js and APIs and unit testing, and really already have their plate full to worry about something else, right? The same way the other side of the house, like they're worried about like security and containers and Kubernetes and upgrading clusters, than spending now time like developing applications and stuff. So anyway, this is like a best practice way of like handling the signals into your program, because Kubernetes will send you, well, Kubernetes will tell the runtime, container runtime in this case will be containerd or Docker, hey, it's time to shut down gracefully the application. So sometimes in enterprises, you have applications that are receiving a lot of requests. Some of those connections take a little bit more time. Actually, this week I was talking to about a customer use case, the gaming industry. They have these containers that they are not allowed to shut down because they have like users in that container, right? So they will send a signal, and then you can configure Kubernetes to wait to a certain amount of time, and you can configure it that the application knows that there's no more users connected anymore, and they're disconnected and go down. So that's why it's good to have this type of things. So to run it, yeah. So you will have something like I'll say here like something locally running. So in this case, you can have Docker, which if you are in Windows and Mac OS, it's called Docker Desktop. If you are in Linux, it's called Docker Engine. So Ubuntu or Amazon Linux, those are free and open source engines. In certain circumstances, some individuals are not allowed to use Docker Desktop in their work computer. So there's a project called Finch, which is open source and doesn't have that restriction, and is a CLI. And this is a project that got inception from AWS, and a good friend of me, Phil Estes. We've been working for years together, and he started that project called Finch, and it has the same flags and they're Podman, NerdCTL. So there's a bunch of them. So I have both installed. So if you want to build this Docker, my app with this Docker file, you will go to this directory here, and we see our Docker file there, and then you will do a Docker build, and as always, you can do that --help to get the help on like what are the parameters you need to pass to it. But it comes down to running Docker build with a
Carlos, when preparing, you told me something like you have the cool Amazon Q command line thing installed. Can we ask that thing to how to build a container?
Yeah. So I have the Q CLI, and you can do Q chat. You can chat with it, or you can do Q AI also. So and then ask like how to run a command. So I usually, for commands, I don't usually chat. If I want more information, I'll do that. For commands, it's called AI, and then you will type like translating text to shell. So
cool.
In this case, I'm not asking a question, or maybe I can ask a question. So like I can tell it a command, I guess, like be very prescriptive, run, or maybe how to build a container using Docker CLI, and it will give me the command, right? So in this case, I have the choice to just like, yep, that's the exact answer that I want. I can just run Docker build -t my image dot. I can edit the command. I can like try again, regenerate another answer, ask another answer or that. But I think that one looks okay. So want to run it? And then this
and the -t will be the tag for the container image.
So yeah,
right?
so the -t that I added here is very important. This is kind of like the identification of your container image. And the uniqueness of this, we're going to see in a minute, is that it will have, so for example, if I do Docker images, I can see like the images I have built. Let me move this
Mm-hmm.
over here. And you can see this one, my image, right?
That's the one we just built.
We did. It says about an hour because I built it like an hour ago, and I'm just rebuilding it again, so it knows that nothing had changed. Uses caching very heavily, but the uniqueness is that my image is a combination of what you pass in -t. It's the combination of like a repository, which is a like a host name. It becomes a URL or URI with the portion of a host name and then a path. So my image is basically my image, and then there's a tag, which sometimes you refer as the version, but it's an identifier, like in Git, right? If you're familiar with Git and Git tags, you're tagging it with a specific one. So I know that for a fact is that one. And then this portion is the image ID, and then there'll be a digest. But the -t is very important because that's in terms of the CLI, these CLIs is they assume that tag has the address where you're going to store the image to then share with someone, or the address of the Docker hub or Docker repository. In our case, in AWS, we have something called Elastic Container Service Registry, ECR, sorry. So ECR is a registry that you can push your images, and that's if you're running EKS in your company, most likely in your company you want all the images in there, so they're close to the Kubernetes cluster and they're downloaded there. So in my case, I just run in since I'm not going to push it yet, I call it my image, and I have a one that is the size is 147 megs. Node.js has a lot of files, I heard. It's not compiled code, right? It's interpreted code, so it's a runtime. That's different from if you're building like a C++ app, an executable, right? Or a Go binary. You only need the static executable. So yeah, so let's do, we can run now the image. So in this case, I can run it. Let's run it. I can do that run. I do -rm because a container can be created but not started. And then maybe I explain this a little bit of the run command. The Docker run command is kind of like a magical command. It do multiple things by one command, which is a good thing because it feels like magic. To some developers or engineers like ourselves, right? We like magic, but we like magic that we understand. I guess that's why I'm like a fan of like magicians, and I go to all the shows when I go to Vegas and reInvent because I like the magic, but I always want to know like, well, what's happening behind the scene, right? How? So the Docker run command does two things. It takes an image as input and it will create a container, but that container is not running. It's just sitting there. So there's a container there, and then you can do to a container, you can do a command to it, say start, and it will start a process, and then you will do a stop, and it will stop the process. The Docker run does two things. It creates the container plus runs the start. So it's kind of like running Docker create plus Docker start. So that's the magic behind it. So the command that I usually use is -rm, because when you stop the container, I mean, we can show this the error maybe. If you just run it and then right to run it again or start it again, it will tell you like, oh, the containers already exist. Like, what are you trying to do? So let's run it. Let's run it to see what happens. So that the app is listening. And then me as a typical developer, I would think that I can do the same thing that I did a minute ago, right? Localhost 8080. And I have chat completions. I'm doing a lot of AI. Let me see. And it failed. Why do you think it failed? It says
That's
it's
a good
listening for
question
80.
because you just started it.
So
maybe different port?
no, my app, I'm putting the app is saying like it's running on 8080, and it's listening in that port, and it worked fine when I run my program in my computer, which let's call it host.
Yeah. On your you executed it and it worked.
So
I don't know what could
in
be
this
wrong.
case, what's happening is this Docker this container image is running in a secondary Linux machine, a virtual machine. Inside my, I have Mac, it could be have Windows. So it's running in a secondary machine. And then on top of that, you need to instruct Docker, like you want to expose to my computer, to the second host, a port on localhost. So, and then this is called port mapping, but it's you have to instruct it like my app is listening on port X, and then I want you to expose it to my computer, like my Mac OS, on port Y. So that's the thing that you have to do. So let's do that. Does that make sense?
So there is no network between the container and the host, and that's the problem at the end. So yeah, now you need to set up that network mapping at
Docker,
the end. That's the problem.
If you do run a Docker network command, there's a network. The thing is, there's not connectivity. So I do ls, and then this is the bridge in Docker. This is the thing that it's bridging that to my host. But in general, you have to tell it like, well, it's -p, and then you notice here that it says 80, and it's because I have Q installed, right? Q is analyzing every command that I do, and it's trying to like predict what is what I need.
You're going to say,
or based on history or things like that. I also have like good auto completion, like from ZSH. So it's a combination of like a lot of helpers in my laptop. So you tell it like the first one is the one like in my computer, and then the other one is the other one, and we can even test it. Sometimes I even forget. So 80, or let me see 1 second. Why is not working? PP. Let me see. I always forget the command. I thought it was PP. Or let me look at the changer command that we were looking at. So when we build it, and this is basically instructions, right? So is -p. Oh, I know what it is. And this is something that happens a lot to me. And you're not going to guess what's the problem with this command. So when you start running with Docker or Docker run command, the last parameter that you pass in is the image. And then the next parameter, positional parameters that you pass is maybe the command that you want to override from your Docker file. So if I have this command here. So if I want to override this versus the entry point, you pass another one. So any flags that you pass, they always need to be before the image that you want to run. These have happened to me all the time. So if you were watching, don't feel ashamed. So yeah, you need to pass the -p 8080, or we can just ask Q, right? For it. And then this will run, and now we can even say 8081 to even make it a little bit confusing. So my app, just a little bit confusing because this is sometimes what happens is in your application, I set the port to 8080, but then I have a print statement that says I'm listening on that number. And yes, I'm listening on 8080, but I told Docker like, well, expose it on my laptop on 8081. So if we run the command again.
So that means if you do a curl, you would need to go to 8081.
And then you go to 8081 and it says hello world. So I
Yay.
think these are the type of things that I want to start. Like running Docker for the first time was alien to me. Like I was not that much documentation. There was no AI. There was no Q. So I would like someone or a YouTube video to show me like the basics, right, to get started. Anyway, and then the Control C is another one that if I didn't have these commands here, I did Control C and it would not shut down. And that was another thing that I frustrated me. Like, why is the Docker not stopping, right? And it will say cannot stop. Then you will do like a Docker key. You will do a Docker PS and see that the app is running. Or for example, let me show it so for people like know what I'm talking about. If you do Control C in your application, whatever an image that you're using and doesn't exit, it's because you can see the Docker PS are the running containers, and you can see that there's a running container and it has an image, a container ID, and then it has a friendly name at the end, which it's a fun way. It's like you always get a random name, and if you want to know the source code, you can go into GitHub and know like how these names are selected in the container GitHub. But then you would do a Docker kill to send the kill signal, right? Because the Control C is sending the sig interrupt, I believe, not sig term. One of the two. I always get those confused. And I know for a fact in Kubernetes is the sig term. So I need that name so I can copy paste the name or the container ID. Let me make this one. And now it's kill, and as you can see, it exits, right? Another thing that people get frustrated with. And then if you don't have Finch, you can do the same thing with Finch. So for example, I can do ls. So I'm in the same folder. If I do Finch, same commands, Finch images.
Got it.
You can see here that the image that we just built is not there. And the reason is Finch is kind of like another application, same thing as Docker. Each one has a VM, that Linux VM where the images are stored, or the engine, I would say like the engines is stored, and we're on that extra Linux VM that is running on. So that's why I need to build it. So if we want to build it, it's the same command, build -t, my image, and then dot, and then, yeah, as you can tell, it's the same text and the same output, the same color. It uses the same technology behind the scenes. It's called BuildKit. Both Docker Desktop and Finch use BuildKit to build these images. And now we run it again. Now my image is there. And if you want to use Finch to run the image, basically we run that command that we just ran with Docker run. We can run it with Finch. And I forgot. Yeah, and then you do the curl, and it's 8081. Notice that if now I kill it and I do Finch PS,
and it's kind of index changeable at
there's
the end,
no
right?
containers running, but if I do PS-A, I'm telling it to list all the containers even if they're not running. So that's why it's still there, and then you have these containers created, and sometimes you can also run it and pass it a name. So it's like name the container X, and then you can do start and stop on it. If you run it with the one that I was saying before with -rm, dash, it's called dash because it's two flags, -rm, is running, but if I do Control C, then it's the old one is still there, right? It's not gone. If I need to remove it, I can do Finch rm and then pass the ID.
The ID.
It's not there. Let me see if this is true. I run it, I stop it, and it's not there. So that's the dash rm. I think people want to know what
that thing does.
that rm does. Yeah. Um, so that's Finch, that's Docker, that's running your app in your computer. The next thing that I want to show is any questions
Let's
so
say
far?
let's just kind of wrap up so
Yeah.
far. So until what we did now was we looked at how to build a container. After knowing how to build the container using either Finch or Docker, we also looked at how to run the container using Finch or using Docker. And there is potentially also other ways to do that, right? But these are the two things that we have been using. And now we are in a state where we might be ready to share this container with someone else after closing that, or what's the next steps from a container development workflow?
Yeah. So let's talk about that. If I want to share it with somebody else, um, um, there's a public repository called Docker Hub that the host name is docker.io. So a lot of these tools, by convenience, they will add that host name. So if you don't pass a host name or a registry, it will default to that. But in the settings that we usually work with, right, with enterprises, with companies, they're not allowed to use Docker Hub. Sometimes like the code is part of the company, right? You don't want to leak it and then put it into a public repository, or any other. There's also Quay. There's many public repositories that allow you to do that, and those are good for like open source projects that are like contributing and the code
Mm-hmm.
is free. When you're in a corporate setting or you're working with a company, this is code that is for the team, right?
Yep.
And you don't want to share it.
Yep.
But maybe you want to share it to be able to run it in some place outside your computer. We want to run it on an EC2, right? In Lambda, in EKS, like I was saying, right? In any of these runtimes. So we need to send the image to a place remotely that then the AWS account on the runtime can access that image and run it for you. So for that, we are going to show the ECR, Elastic Container Registry. Let me see here. And the way that you work with typically is if you need to tag the image with the host. I would say like the -t, right? The thing that maybe people get confused is sometimes when you do a Docker push to maybe a Docker Hub or Quay, it will create the repository automatically under your account. In ECR, we want to be more explicit because we want to control like which images get created, how many there are, who's creating them, permissions to it with AIM. You want to have the ability to be able to control that. So in ECR, you have to create the image. And I think I showed, I tried this morning. We can even say to Q and then do a chat, right? Or Amazon Q or the CLI. You can say, how do I push a new container to AWS ECR? And it will give you kind of like those instructions that I just said, right? There's also, so in here, it's giving you the instructions that you can do it in the.
Yeah, but it includes all commands at the end as well, so that's pretty good.
Yeah, so it gives you the command. So I can do it here. I can do it in the console, right? ECR, create repository, the repository name, and my repo. What do you think? We'll do a CLI or do it in the console?
Let's do CLI.
Okay. So let's do this one. So
the console should be read-only, Carlos. At least that's my
yes.
That's my take on it.
So in this case, you're authenticating here, and it told me to. So one of the things that I usually do is this command. Maybe people are familiar with this command. Sometimes I have a lot of accounts or a row, or I just assume a row. This will give me like which row I am. So in this case, I'm in this account. I'm this user. So I'm going to connect to it. And just to test, like, so usually developers configure the AWS CLI and credentials. They will use the AWS or the configuration file, which you can assume different credentials depending on the account that you have. But in this case, I have it default to one account, default to one region. So we should be able to run the command and it would just work on the place that I want. So let's look for that command again. So it says to create this, let's put it here, and then I'll call this one hello world. And hopefully there's no, my account, this account is for me. Like if I'm sharing it with somebody else, probably they already have hello world taken and it will error out. Or maybe I created this one before, I don't remember. So we'll see what happens.
We'll see.
So it got created and it returned that it's okay. I even have an RN and everything. Like it didn't take that much.
And we even got, now you already closed it again, but we got an ARN of the repository, because I think that's what we're going to need next.
Yes. So the next thing that I need is this piece that it says that I need to, if I'm going to be using Docker login, I would need to get the credentials, right, to pass to Docker, because AWS CLI knows how to talk to my account, right, how to authenticate to my account. Docker out of the box doesn't know how to talk to my AWS AIM to get credentials to be able to push the image. So this command in here, ECR get login password, will give me back a password that then I pass to Docker, and it's saved. And it's valid, I believe, for 12 hours. But then after 12 hours, if you try to do something with Docker, guess what's going to happen?
It will fail, I guess, with an authentication error. Yeah.
One of the things that you can do to avoid this is, I wanted to show is that, I think I even have it here. We have helpers for this type of things. Finch have it default, so we'll show Finch in a minute. But there's this project called Amazon ECR Credential Helper, and basically it's a CLI that you install on your computer. So I look for the Mac OS, so I already ran this, and then this will put a binary in your computer, and then you can configure Docker to use this binary, this program, to refresh that token. So you're always like have authentication to your registry. So the way to configure it is you go down to the configuration, and it says that you can switch your credential store to ECR login, and this will tell it like, hey, you have to use, you would use a helper, right? You would use this binary that is here. I have it in my computer. So if I do which, I have it there. And then you will configure it. So you also can configure it based on this section here. So if you have a new version of Docker, which I have, they improve the integration. And basically you can put here saying like, which places are you going to go to, and then use ECR login. And this is useful because sometimes it's a Amazon AWS.com, maybe it's GovCloud, maybe it's a different repository that it needs AIM authentication, right? So it's very flexible. So let's do that. So if I copy,
let's use that.
So I copy this, and I open that file. It says docker config, and then I will add this as another one. I'm going to leave this one in here because that's the default. Maybe you use it, maybe you don't.
Yep.
And I will add another entry here. I think I did it something that I shouldn't. And then I can start creating I can paste it here. And actually this is the internal, right? So the key is this one. So also for public ECR, so we have images that are in public ECR, and these are useful to use because a lot of like Docker images that are public, they're mirror in public ECR. So a lot of images that are like public from open source projects. And also I believe ChainGuard's in the process of putting them here. I don't know if they did, we were talking with them recently. You can just get them from here, and then this is a server that maybe when you run your runtime in AWS is closer, right? That registry is closer to your region, and you're getting that from a public place. And then
Yeah, and does that influence the traffic, how it is counted? Because traffic costs are sometimes a problem. So if I use public ECR, does that go through internet traffic or is that internal AWS
I
traffic?
don't know all the details. We can follow up on that one, that specific
Yeah,
one.
that yeah would be interesting.
So to get access to mine, saying like this is the host name of the registry that I just created, right? So I can even say AWS if I want to list it again, right? Maybe I need that information. So to be sure, I can do ECR list images or list repositories. Or do list images. Oh, it's list images on the repository. So maybe I need list list repositories. No, I was doing it a minute ago. Let me see, help. There should be a bunch of list commands in here.
I guess. List images, there it is.
Yeah, but these images didn't quite give me what I wanted. Because I think it's going down to the thing.
Ask Q.
I'll do the AWS
QAI
SDS
or whatever.
get caller identity, and then just copy my account ID, right? I'm wondering if I can put just a star. We'll do that tomorrow. But I can put that here, and I'm in US East, US West, sorry, West 2. So any images. So if I start creating, not images, sorry. So there's the repository, and then you start like adding images, and each image has a tag. So as just like update the tag, those are images in the console. So that should be it. So now if I do a Docker, right? I have Docker images. I have only my image, right? I call it my image. Remember I said that we already did the Docker build.
Yeah, we called it.
But then now
image,
what you can do is you don't have to build the images again and again and again. It's just an artifact, and it has a digest, and it has image ID. What you can start doing is creating kind of like aliases, which is creating, you're creating tags. So we can take my image, which happens to be the one that we're using, right? And it's latest, and then tag it with my kind of like ARN, but it's not ARN. It's like the repository / my repo, which we call it hello world, and then the version that we want. So in that case, we can do that. So we can do Docker tag my image, and now I want this to be something. No, that's not the right number. So it'll be something like this.
Yes, and then hello world.
Hello world.
Yeah, that looks good.
Why is not terminate? It's grayed out for some reason. And we'll call it 1.0.0. So I'm calling it 1.0.0 because sometimes some tools, I believe maybe Kind, we're going to see in a minute. If you use latest, it will try to connect and try to get the latest version. So the latest, using the latest tag is kind of like both a bad practice and an anti-pattern. Right? It's useful for like, publishing something that it's the last one, but tomorrow the latest can be something different, right? And in software engineering, that's kind of like bad that something works today and then tomorrow doesn't work. So if you tag it with a familiar version or a string in here, it's much easier to know like which one is the one that I want, which one is the one that is already cached. So you don't have to go and fetch another one because I told you I want .1.0.0. Let's close this. And that was tag. So that's not even connecting to AWS. So the next thing that Q said was to push. So I can do a Docker push and then push it here. So it would do Docker push. Basically, you would use the same information that you just typed, right?
And yeah, and that means it will now search for the Docker image with the tag locally, and it will push that
Yep.
to that repository
So
at the end.
if I do Docker
Okay, cool.
images, now I will see this under Docker images. So that command Docker images is always good to have around. So,
and do you recommend people to do this from their local, or would you normally integrate that in a CI/CD pipeline?
Today we're doing demo festival, right?
Okay. Yeah, just
but
checking.
As a best practice, right? I said, like, when you onboard into your company usually, if they're already using EKS or maybe they're running containers, for example, they will have a CI/CD pipeline where they will tell you, like, you have to put this node index your program, right, in a certain Git repository, and anytime there's a merge request, I think it's called a GitLab, or pull request, and it gets merged, and your program gets updated, an event should happen. It should trigger a CI job, right? And that CI job could be, and I think you have a lot of videos on this, like it could be a GitHub action, a GitLab pipeline. It could be a code build and code pipeline. And then it will take these files, and then on the server, right, on the remote server, it will build the image and then do this exact same steps. It will push the image either with Finch or Docker, right? It will do the build, and then it will push a new version of your application. So best practice is do a build and a new image when there's a new Git tag. So the event should not be when you merge to main, right? The event should be when you tag a certain point your software, saying here's a new version for a patch release, which we use semantic version, it will be the last digit, or here's a feature or a change without changing the API, and then the major API, so you have follow semantic versioning. And then this tag will continually change. And one of the things that we have in AWS, when you push to ECR, doesn't matter where you push to, if I can push even from my laptop, is you can trigger a scan for security problems on that. And then also, like, you can configure ECR. I think it's called enhanced scanning continuously, like, because it could be like there's no way security finding today, but next month on that same image, there's a security finding reported somewhere. So the scan would run maybe a month from now and find, like, hey, this image has an issue that was built a month ago. Notify someone, and then potentially is not in your code. Potentially is one of the, I can show the package, Jason, is one of your dependencies. Usually it's the case. Or it's maybe the base image. So that's why it's good to have something like ChainGuard, or an image that is very small, or image that doesn't have any files with multi builds. And then you will either upgrade the image, and then sometimes you would need to put here the digest, so you know exactly that image that you're getting.
So you pin on that version number at the end.
Like, this would not look in production. You put a digest saying, like, a year from now I come in, this is the base image that I'm going to be using, right? And my app continues to work.
Okay, so Carlos, we've been recording. There's a digest. Yeah, we have been now on an hour already, and we didn't really get to Kubernetes yet. So sounds like complex stuff. So we now managed to get our container push to ECR with what we did. That doesn't really mean that we're now doing Kubernetes.
No.
So how do we now get ourselves into doing Kubernetes?
So one of the tools that you can use locally, and a lot of companies, don't even use Kubernetes locally, but we're going to show it today. I think it's useful to know the magic, right? Understand that magic that we were talking about. And there's multiple ways to run Kubernetes locally. 3 of them are like that I'm very familiar. It's Minikube. is from the upstream project. Kind is also from the Kubernetes upstream project. Docker desktops ships a specific version of Kubernetes. The other two, you can switch the version. You can have multiple worker nodes. And then for today, we're going to show Kind. So with Kind.
Yeah, so I already, well, I said to you, I started my Kubernetes journey a few months ago, right? And there's 3 tools that you mentioned up there that I haven't heard. There's 2 of them I haven't heard of. So I've been using kubectl, which is, as far as I understand, the command to execute Kubernetes commands targeted towards a cluster, right? With a lot of possibilities. So that would be the first one, but the other 2, I don't know. What is that?
Yeah, so kubectl is, you will have kubectl installed as a binary, so you can brew install or download the correct version of it. Kubernetes and kubectx is when sometimes you are connecting to multiple Kubernetes clusters. It's basically a helper kind of alias bash shell command that helps you like switch which when you run kubectl, let's say get nodes, and this will fail because it's not connecting to anything. You can have a file under your home directory with multiple configurations for multiple clusters. So kubectx would allow you to switch the context of which Kubernetes you're talking to. So that's useful when you want to talk to one EKS cluster and a second EKS cluster and a third one, maybe dev, staging, and production, and also talk to the Kubernetes local in your computer. The other one is sometimes when you run kubectl or kubectl commands, you're working on different namespaces. So sometimes you do get kubectl get pods, and it will use whatever is the current context as a namespace. So you don't have to always pass the namespace name to specify which namespace you want to work with. So that also to switch your context in that config file that you're working on. So it's a two convenient CLIs to switch. That way, when you are copy pasting maybe instructions from a tutorial, right? They just work out of the box because they may be working on a specific namespace. And this is also useful for multi-tenancy environments where like maybe you are in a team and there's other teams sharing one EKS cluster, but you're only allowed to see maybe 3 namespaces and not the other ones. You're always working on your team's namespace. And you don't want to pass to your shell scripts, your automation, or your commands the specific namespace. Just set the context and then everything else works. That makes sense?
Okay. Yep, it does. Cool. Thank you.
So yeah, let's look into Kind. Kind is a CLI utility that you can create a very minimalistic cluster. So the commands to get started is you run something like kube create cluster. You can also, like you can see here in the autocomplete from Q, you can pass it a config file. So if you're following a tutorial or somebody's giving you specific instructions, you can do that, and that would allow you to change certain configurations probably on the control plane, how it behaves. In something like EKS, you don't have to worry about that. We own the control plane, and you don't have to configure certain things that come out of the box configure. So this is how fast you get a Kubernetes cluster. It took less than a minute. And people say like, how do I get a Kubernetes cluster? It takes less than a minute to run.
That is the power of Kind.
So this is the command that you saw kubectl do. Is an alias to this. It's like change the context, see the context that you're working with. And then you have a cluster. So typically when you work with Kubernetes, you will do kubectl get nodes, and you will see that you have, this is a very one node is both running the control plane and it's allowing to run apps, so you don't have that many.
Okay.
It's version 1.30, which is the latest GA version. Also EKS supports 1.30. Go ahead.
Hey, cool. That kind of latest version
and
directly.
you can specify which version you want. So sometimes, your team may not be using 130 yet, right? They want 129, and you can specify 129 so it matches your EKS cluster version, right? So if we want to run an image, is basically some of the commands to run it are. You can see my terminal fine, or is it too small?
Yes. No, it is fine enough for me to read.
Yeah, we'll make it like this. kubectl. So the hello world to get something running in Kubernetes is you can do it from the CLI. So I like to do an alias like k equals kubectl. A lot of people do that. One of them, I didn't for a while, but I just went with the flow. You can do k, and you can also configure with autocomplete, which is very useful to configure your shell with autocomplete both for k and kubectl. And on top of that, before a few years ago, we didn't have Q, so we didn't have like a prompt like this that told me like the commands, right? So Q has been helpful.
So you needed to remember them.
So if you want to, in Kubernetes, we have a thing called deployment. So you can create a deployment and give it a name. So in this case, I can give it hello world. And then, as you can see here in the autocomplete, then I can just give it an image. And this image is the container image that we have. And then if we run it, it will create a deployment with one replica. And one replica is a pod. So a pod is I would say the container of the containers. It's containers everywhere. But it's the single entity in Kubernetes where like you work with the runtime. The thing that is active, that it runs your programs, is called a pod. A deployment is an object that manages how many versions, how many replicas you have, and then what is the configuration as you create more pods and do the updates. So one of the things that I typically do is get all. That's a command that will give you everything. If you cannot remember which commands to run, you get all. And then you get multiple things in here. You get one that is the pod that we just created. It has a dynamic UUID because you're going to be creating multiple replicas. You have a service. We'll look at that in a minute. And then here's the deployment that we created. And as we can look, we can even see the status on the get all. And we have an error message.
Oh, there's an error message.
And to investigate.
Let me guess what that could be. Let me guess. I'm kind of good at guessing. Usually, maybe the kind cluster is not allowed to download that image because we're pulling it from that ECR. How can we identify whether I'm correct?
Yeah, and the other thing you can also do is ask Amazon Q here in the console, right? What is wrong with my app? And then it will give you kind of like, well, there's image pool. Might not, it can explain. So if the person doesn't have you beside him, you can use GenAI to ask questions, right? So basically, it will give you more information about how to debug it. So one of the things to look deeper, like you said, that was a good guess, is you can use the command called describe. And describe in Kubernetes, what it does is it gathers the information about the configuration, but also at the bottom, it puts the events that are happening around that app. And that's not your logs, because the app is not even running yet. So you don't have logs. So the only thing that you have is events, and Kubernetes is an event-driven kind of application that emits events on everything that's happening. So you can even do get events and see all these events associated with the pods, right? You can see them all here. Or if you want to filter based on that specific pod, you can do k describe pod, and then the name of the pod or all the pods.
Then I get all information that the control plane has about that pod, essentially, right? Okay, got it.
Yeah. So in here you can see like a nice events at the bottom, and this is how you debug Kubernetes, right? It says like, I got successfully the pod got scheduled into a node, so it has enough space to fit in there. I'm going to attempt to the kubelet, right? The kubelet is one of the components running on the worker nodes. I'm going to attempt to pull it. It failed. to pull it. It says something pull access denied. Repository cannot access it, and that's the error, right? So it's because this Kubernetes cluster doesn't have access to ECR. So one of the things that you can do is configure a token and give it to Kubernetes. In this case, in here, and since it's running in your laptop, it's going to be kind of like difficult to refresh the token. You can go down the path of like figure out how to configure this kind cluster to use the kubelet to authenticate and all those things. But for now, the easiest way is kind offers a way to, let's say that I didn't want to push the image to a repository, but I have it in my laptop, right? Maybe I'm in an airplane. And I don't want to pull it down from the internet. I can use a kind command called load. Load, and you can now load. You can load images from a tar or from Docker inside that Kubernetes cluster.
That is cool, because now you can tell him load this image with your AWS credentials from ECR into your kind cluster, and then it will find it from there. That's cool.
Yep. So you don't even we don't even have to be an image from ECR. It could be my image. We can like switch it to my image, and then it will run. So to get this is kind load Docker image, because it could be an archive. Somebody can send you a zip file or a TGC, for example. You Docker save, right? That TGC sent it to someone. And then somebody can load it. So that's why Docker images are portable, right? So image, and then we pass I think it's just the image name. There it is.
Cool.
And now it's loaded. If you want to like troubleshoot this thing, you can also like kind of SSH into the worker node. So this is a command that basically, if you want to know what's the magic with kind is just running a Docker container. Your Kubernetes cluster is just a Docker container running in your laptop. So and it's running kind of a Linux operating system that is kind of like your worker node. So you can execute IT bash. Basically, you're like SSHing into it. Let me see.
You would
happen Docker control. So it's control plane, right? It's called kind. Oh, it's called kind control plane. Sorry, my bad. You can execute a command and then get a terminal.
That's good. So it requires Docker desktop installed at the end. Okay.
Yeah. So now I'm here, right? I can run PSEF. Like, I mean, like, this is kind of like not for the developer, but if you're an IT person in charge of Kubernetes, then you can learn here. And this is the thing that I used in the book club. We did a session about like 4 Fridays for a book starting for CKA, the certification. And this is the environment that we use to practice of like all these commands in Kubernetes.
What you're showing then at the end also means that I could run kind within my CI/CD pipeline as well if I want to, and then run.
Yep.
Okay. Well, that sounds like a follow-up that I would like to take with you to making sure that we can run kind in a CI/CD pipeline that then enables us to run integration tests.
Yep. For years, people have been doing that, and kind have been getting better, and to the point that it doesn't require root. And in the Canoe project that I was mentioning, we have enterprises using kind in, for example, in GitHub Actions, where they deploy a kind cluster. They deploy, let's say, something like an internal developer platform or all the utilities, and they try to deploy the app, and then they run end-to-end integration to make sure that the resources that deploy in Kubernetes are the expected resources. So yeah, I wanted to show one command that is also good for troubleshooting. So if something's going wrong with your images, you can do inside here. There's no Docker. Let me see. I should not be Docker. There's no Docker because we removed Docker from Kubernetes a few releases ago, and now we have containerd.
Okay.
So containerd is what's running, but there's different CLIs that can talk to containerd, and one of them is cryl-ctl. And then in here you can see some similarities, right? I can pull an image, I can do PS, I can do RMI. So the same things that you had before, you can do it here. You can do things like, I think pods, and you can see all the pods running on that worker node. You can also do images. So if for some reason I should have done this first and then the load.
Of course, and we loaded it just missing, right now. Yeah.
Right. And we loaded it in. So basically we did it here. So that's kind of like, how do you troubleshoot when something is not going wrong? You can go inside your Kubernetes cluster, right? And inspect like what's going on, why the image is there, what is running, and also like practice for certification if you want to get the certification.
That is good.
So is our app running?
Yay, cool. That means now
our app's running. Yeah. And why is it running? I didn't have to tell the team to retry, right? That's the essence of Kubernetes and the kubelet. It's like it will continuously try to get to the desired state. So Kubernetes is based on promise theory, right? This is my desired state. You figure out how to get there and continue to try.
So it's going to try to reconcile to the target state until we are done at the end, until it reaches the point where you want to be, correct? Yes, okay.
Yep. Yeah.
But now
but the thing is, I'm
exactly.
a developer.
That was my next question. How do I now access it? It should just work, right? With curl localhost 8080? No.
No. Actually, no, if we do the curl command again, even 8080 it's not there.
Carlos, you broke it. Let's get it fixed.
So let's get it fixed. One of the things that you can do is just port forward, which is directly going into this pod. To basically port forward, what it does, it creates a proxy from your Linux computer using the Kubernetes API, and it will proxy any HTTP requests from the kube API server to that pod. So it will select one of the pods. So if you have multiple pods, you will select one of them and will connect to it. And the kubectl port forward command is a very powerful program. I think I would say this is the most useful one. We'll do this here. That people use. So in this case, I would need to run port forward on the pod, but since I don't know this pod name will change a lot, right? Tomorrow I come in and delete it and come back. It's kind of like not useful to like find the IP address or select one of them. So in Kubernetes we have something called a service, and a service is something that it will go on top of it, and then select one of the pods. So the way you can create a service is with kubectl expose the deployment. So if we run this command, and we give it the deployment name, which is hello world, and remember, like, is this error is saying that we just ran the container. But Kubernetes doesn't know that my program, right? If we go to the program, my index.js is running on port 8080. I didn't tell it to program. I could, I forgot to give it that instruction, and it will work. So I need to pass the dashboard. So I can do dashboard 8080, right? And now I have a service. It's telling you that it's exposed, but it's not exposed to my computer. It's exposed in terms of like Kubernetes. Internal in Kubernetes, there's going to be it's called a cluster IP address that will map it will be sitting in front, like something like IP tables or kube proxy will sit in front of these other IP addresses. So if we do get services, SVC, you can ignore the first one. The first one is to access the Kubernetes API internally, sorry, the second one. The first one that says hello world, it says now that it has this IP address, but this IP address is not one of the IP addresses that my computer can reach. It's a 10 dot something. So this is where now we use the kube port forward. So if we do kube port forward, I'll be using the kube API server. You can see here, I would select the service, hello world, and then maybe I want 8081 to expose to 8080 on one of the pods that is behind this IP address. So this way, these instructions kind of like work out of the box. So you don't have to put the pod name. And now I should be able to hit it, right? So let's do the curl again. Oh, wait, my bad.
Yay.
And I have hello world.
Cool.
So now my app is working on Kubernetes.
And now I need to have that kube CDL port forward. I need to have that active on the left-hand side. Okay.
Yes, because it's a kind of a proxy. It's proxying from your computer, so you can leave this behind the scenes. But as you deploy more pods, you have to run it again. I think somebody created even like a Mac OS app to like handle all these port forwards locally. It was handy to do that. But this is usually when you deploy a sample application or somebody gives you a container, you run it in Kubernetes, and then you want to access it. This is kind of like the happy path to get it up and running using the service. You can also use the deployment, by the way, but I use the service because that's the most common way that people do it, and it looks like in production. Like it looks like when you're going to run it on EKS, and then to exit, just Control-C.
And now the port forward is stopped again. Okay, cool. So now we have seen how to run an application on kind and exposing it so we can read it from the outside. But that's not the end of the story that we wanted to look at today, right?
No. So the other aspect of it is GitOps. So this, I just did the deployment using imperative commands. So my desired state was kind of like a kubectl create deployment. I can go to the next level and create YAML files. So this is why in Kubernetes we say that we use a lot of YAML, is because I have here a Kubernetes folder, manifest, and I have a deployment.yaml. So I can do the same thing that I did with my application and do a kubectl apply and deploy this app and get it up and running.
So that means that we're going to store something in a Git repository, potentially on GitHub or Code Catalyst or Code Commit or whatever. And then that we have, and I think you had that on the README, we have two tools that would help us to make sure that we kind of synchronize that. So that was, I think, Flux and Argus CD that you had as examples there.
Yeah, so GitOps is a concept. Using GitOps is kind of it's the native way of like working with Kubernetes, where I mentioned like it's the Prometheus theory of like the desired state, and then giving the system to the instructions like this is the desired state that I want. So it can be expressed as a configuration file. This could be .json, but it could be .yaml. So a lot of people use YAML. You give this configuration to a system called GitOps, and this is a program that consistently fetches the configuration, and it makes sure that the configuration is in Kubernetes, and then the secondary one is Kubernetes make sure that is running. So one of the tools is called Argus CD. It's a open source tool, part of the CNCF. Flux CD is also part of the CNCF. Argus CD comes with a GUI or a UI where you can like create a definition of an Argus CD application, point it to a Git repository, for example, like a folder in a Git repository. And as you update the configuration of those files, so in that repository, you will have something like this, like a deployment, a service that we saw, right? This not goes there. The service that you have, and then an ingress, which is another object in Kubernetes that it allows you to expose, like what we did at the bottom, like the port forward, but it's more using for example, in EKS, you'll be using a load balancer controller, or an NGINX in front of the load balancer controller. So this is how you expose your applications, for example, to a host name like this, my app localtest.me, and get it there. So let me show you how to run Argo CD super fast. And if you want to run in your computer, and then if you have your YAML files, these YAML files are not in the internet, but I'll show a different app. Helm is a package manager of Kubernetes, very popular in terms of getting software from third parties or from open source, including AWS. Some of our projects, like the AWS load balancing controller, comes in a Helm package, and then you can download it and install it. Argo CD comes from the CNCF. So I can run Helm and then Helm install, and then this will create a new namespace. It will deploy a set of deployments, stateful sets, secrets. It's like installing software.
So it's like Yum or something similar. It's like Yum, or
Yum,
like a package manager at the end.
Yeah, exactly. So this is the output that people put in the Helm charts. And then to log into Argo CD, you will have something like the initial credentials, but you can configure with single sign-on with a OIDC or something like that.
And that gives us the password of the administrator account.
Yeah, the admin. So that's the password.
That is generated initially, right?
Yeah, it's generated initially when you install it. Like it's like a seed, a random password that gets created. And then it's running in our computer, in our kind cluster. So if I do get pods, I don't see it because it's not in that namespace, but it's in the Argo CD namespace, and we can see a few pods running here, like application
that was
controller,
fast.
application set, Redis server, repo server. So this server is the one that is an API server, and both a UI has the UI. And again, once you know the basics of Kubernetes, the rest works the same way. That's kind of like why it's becoming a standard. So it's a trade-off of like complexity for certain things, but that complexity at a certain point, it becomes just standard of doing things: configuration, secrets, accessing it, running it, rebooting it, updating it. So let's port forward Argo CD and open it in the browser. So now it's running on localhost 8080. So if I open here localhost 8080, in this case, it runs in HTTPS by default, so it doesn't match my host name. So I'll go, it's internally only, but in production, you want to like run it with a SSL certificate and everything, right? For example, in EKS, we'll type admin here, and then that password that we save here in a file, and then you are located here, and then sign in. And then this is running in the kind cluster, and this is where you get in Argo CD. So in terms of settings, user info, documentation, everything.
You get a full-blown Argo CD.
Would allow you
that's good.
Yeah, super fast to get Argo CD up and running. Now becomes the secondary thing. Like, how do I deploy an application, any application that is available anywhere? So let's test something out. So if I do create application, and I put here like test, and the project name is like this is project name is useful. You have to select one to secure your applications. I put them in a boundary aspect of it. You can sync manually or automatically. So we'll leave it default manually. Automatically will be like anytime there's a change in a Git repository or a new version of a Helm chart gets released, because you also can deploy Helm charts from a server. it will automatically sync. We'll try to synchronize, so you don't have to like no go to the server and then deploy the application. It automatically deploys anytime there's a new software available in the branch or specific tag or something like that. So I'll leave it manual. And then the minimum information you need to provide is like a URL of Git, for example. So in this case, we can use the Argo CD has a example called guestbook, but it could be any application out there. So this is a folder that we can select. So I'll select the GitHub repo.
But in this case now it needs to be a public Git repository.
Exactly. So I'm going to deploy like an app so you can see it up and running, and then we'll see like the problem that we're going to hit. Like, how do I deploy my app? So if I select this, then I can select one of the apps that it has, right? The guestbook, customize Helm. So it's like an example of like all the different ways that you can configure YAML in Kubernetes. The cluster, we only have one. So it's usually called in cluster. The namespace,
guestbook.
You have to select.
Yeah.
We can put guestbook. But
it doesn't matter.
In the UI, it doesn't matter what you do. Put in here, and I think that's it. And then we create it. Like you can also edit the YAML and just copy paste some YAML of an Argo CD application. And we run it, and it says out of sync, meaning that these are the things that it wants to create, but yellow shows like they're not there.
Not yet there.
So if I do in the terminal get pods, I only have my hello world. I don't have that guestbook thing. So I have to manually sync and then synchronize.
That's because we chose manual sync at the beginning.
Yeah, we select manual. So it depends on your environment. Like maybe in dev, you want to do automatic syncs. Maybe in production, you want to wait to a window, right? Until maybe Tuesday at 1 p.m. you do patches or something like that. And then the automated system can talk to a REST API to Argo CD saying like, yep, time to synchronize. And this will give you this. The other thing that it does is if somebody goes and by mistake goes into Kubernetes and it changes something, it will go into out of sync like, hey, somebody changed something in Kubernetes. That's not the desired state. So that's the benefit of Argo CD and the constant reconciliation. That it doesn't matter if you even do it manually, you get notified. You can have notifications through Slack, email, whatever. It's something or someone or some system by mistake changes the wrong thing, then you get notified. So manual is not, it's also useful because you have automation in all the places.
Yeah, that makes sense. But Carlos, there's one thing that you promised me at the beginning, which was like, I want to do this locally only. And we just downloaded, or we just accessed the repository on GitHub for deploying this guestbook app. So how do I get this kind of to work only local? Yeah.
So the next step of this is I wanted to introduce you to a program called Canoe. And Canoe is a project, an open source project that AWS started with some. We started with some companies. These companies are at the bottom members, like Twilio, Intuit, Autodesk, Salesforce, and is a set of a community to try to build that GitOps development workflow for platform engineers and also for developers. And it uses Argo CD. One of the architectures is using Argo CD, but it's to create a internal developer platform, including a developer portal. So one of the tools I'm going to show the minimal functionality is called the IDPBuilder. So if you click getting started in here, the IDPBuilder, we also have patterns for EKS. But IDPBuilder is something that we also support, like I said, Finch or Docker Desktop. Is a CLI that you can download. And when you run it with the create command, it automatically creates you a kind cluster, automatically installs Argo CD, which we just did, right? Manually, and then installs the missing piece, which is a Git server inside that kind cluster with a UI. So what we can do is run this system, and then this IDPBuilder can synchronize the folders on our laptop to this Git server and synchronize any Argo CD YAML files with instructions saying deploy my app from Git that you just like sync from my folder.
Okay.
That would cut the time that we just spend trying to do everything by hand, right? But I think one of the things that you told me was you wanted to know, like, if I show you this, it will be like magic.
Yes.
But how this magic works, right?
Yes. That's the important piece. You need to understand that, because if you hit an issue, you don't have a chance otherwise, right? So you need to understand how you build that up at the end, right? And now introducing that IDPBuilder is maybe something that after I understood how Kubernetes works, I can now use this to go some fast way, right?
Because it's building on Kubernetes. So if you jump into this magic and like, why this doesn't work, or how does it work? Well, it works on Kubernetes. Like, well, how do Kubernetes work? Then you ask, but you have a foundation, like the Canoe project is built on top of the assumption that the programming model and the framework is all Kubernetes, but on top of that is everything is GitOps, the system. So let me see, we can show you quickly how it works. So let me shut down this system. And basically you can download the CLI from this repository. I think we did a release this week, 0.5. This version was 2 days ago, so you get to see the latest version. And we welcome pull requests, but we mostly welcome ideas of what are the things that you want to see that are missing. And usually I open a few of those, and the team is so great that they fix them by the next week. As I hit problems and as I do demos. So yeah, the only thing that it takes is that IDPBuilder create. So let's run it, and then this will create a secondary kind cluster, so it doesn't mess with your workflow if you have it. So if I run IDPBuilder, create this system, as you can see here, is creating a kind cluster, which we already learned in the last 30 minutes. It's creating it with a configuration that you can override also. So you can see things like here. And if you can notice here, this is something that we added in the last version. It says containerd patches. And you notice here that it has, for containerd, configuration telling it like to be able to work with a container registry that is running inside the kind cluster. So we're going to give you, starting, I guess, this week, a third capability. So installs kind, it installs Argo CD, it installs a Git for Git server, installs a container registry, and it configures also Nginx to be able to create ingresses with YAML, and they automatically get exposed in your laptop with one single command.
Cool.
So we'll give it a minute, and we can see like things starting. So if I do,
that gets you started really fast, because you're already like 50% of the way on deploying your own, 80% the way on deploying your own app on that cluster using GitOps. And essentially that's what we wanted to reach.
Yep.
Right.
So if you are in the situation where you were working with this the platform team or the DevOps team, and they're telling you like the way we do many applications, maybe the company or the organization has hundreds of applications, they say like we cannot keep track of all these unless we use GitOps, right? And then that you go back to the drawing board, like, how do I get started with GitOps? Like, how do I use
How did it set up that URL?
Go ahead.
On the left-hand side, we have an URL now. How did it set up that URL? It set up something in my DNS, so
no.
ipconfig.
So I have a URL now that I can open. Let me open it.
Yeah, but in order for me to resolve that, it must update my etc host or something like that, right?
Of magic. So it doesn't update your etc host. If you do ns lookup in your laptop, you say foobar.localtest.me, you get.
Don't tell me that works. Oh my gosh.
Right?
Cool.
So this is something that it works in your laptop today.
Also, so IDPBuilder works in Windows, macOS, Linux, everywhere.
Yeah, yeah.
Cool. I didn't know that. Now I learned something. Magic.
Yeah. So I didn't know this either. I used to use something called other systems that you put an IP address
Yeah.
.io,
Yeah.
.gz,
Yeah.
.zip, and then we'll give you back that IP address. I think there's two systems that will give you back. I don't remember the other one, but it will give you 127.0.0.1.
Okay.
And the thing is,
Cool.
as you saw here, is a little bit of more magic, since you like magic, is if you notice down here, when we created the kind cluster, you can add extra port mappings, meaning that you're telling kind, the Linux machine that kind is running, hey, by the way, export this port A443 on any process running on A443 inside that Linux machine. And what we do is we install nginx with host port A443. So when I access localhost A443, it's hitting that nginx, and that nginx is doing its job as an ingress controller, routing it to the ingresses that are defined in kind. That makes sense?
Cool. Yeah, it does.
So now we have Argo CD, and then if you want to get the secrets, you can run IDPBuilder get secrets, and then you get a couple of them. You get them for Argo CD, and you get them from Git T. So for example, now if I want to log in into Argo CD,
that is now the Argo CD instance that we are running through IDPBuilder.
Yes. So now, as you can see here, if I do kind, I was going to do get clusters. I have two clusters in kind. One is called local dev, one is called kind. The local dev we're going to switch soon to be named Canoe. But this is the one that we're working with.
Yep, that's the one we created. The kind one is the one we created earlier.
So remember when you asked me what is this command used for, kubectx? So if I run it, now I can see I have multiple Kubernetes clusters that I can connect to. I can connect to the kind, which is the first one we were working on. I can switch the context to kind local dev, which is the new one in Canoe, or any remote EKS clusters that I have. So if I think we log in, right?
Yeah, let's do that.
See what's happening here also? We're also eating our own dog food. So Argo CD is not empty.
That means we have
Argo CD, it's deploying itself. So you can reconfigure Argo CD with Argo CD. So Argo CD now is being deployed through our GitOps, nginx, the controller, also being deployed through Argo CD. And then our Git server, well, where is Argo CD pointing to? It needs to be pointing to Git. So it's not pointing to GitHub or a Git repository that we created on the fly. We are running a tiny Git server. It looks like GitHub. And this is where we are. This is our Git repository where we can put our YAML files. And IDPBuilder is putting YAML files in there. So let's see how this Git server looks like. So if we go to, if we look at the nginx, so a little bit of the, let me copy this password because I will need it. If I do kubectl, get all the ingresses in this system, I will see that I have two. One is host name Argo CD map to that port, and the second one is git t canoe localtest.me. So I can go to.
You can use that as a Git endpoint as well.
Yes. So I can go to git t localhost localtest.me. Sorry. Go in there, and now I don't even have to log in. Well, that's something to take account. If you run this in the cloud or something, the files are public by default. So be careful. Don't put any sensitive information and then put this. And from your computers, you're okay. But if you're putting this in the cloud and then trying to put a load balancer on top of it, any files that you put in here, which should not be sensitive, right? But you can put a secret.yaml are there. So for example, git t is being deployed from this Git server. So familiar, right? Code, issues, pull requests, packages, You can Git
That
clone.
is cool.
It's a Git server that you can start like either for learning purposes or for testing or for troubleshooting, or in our case in Canoe, for building a platform. If you're a platform engineer, you're building a platform using these tools and you're doing it locally. And when you make a change, then you mention it.
Cool.
The CI/CD pipeline will run IDPBuilder, would put your platform in there. It will run end-to-end tests, maybe through the APIs of Backstage to create a new app, see that it's deployed, check that everything got deployed correctly, and then end. So you can run end-to-end platform tests with the system.
This is cool. This is great. A lot of magic, but a lot of cool stuff.
But we don't see our app. Let's
really
take 5 minutes to deploy our app.
Yeah.
So
yeah, let's get that app now. So my next question would have been, how do I get my app into that environment now?
Yes. So remember that we were creating apps manually here, right? This is the old one, right? This is the new one. I can create a new app, right? And I can start putting my information here, or I can go ahead and create a new repository and git push files in here. But that's old school. What we need to do is everything is infrastructure as data, right? As YAML files. So you can put the YAML file of, like, this is a definition of an Argo CD application. So to register our application, we just need to tell Argo CD, here's a YAML file with an Argo app. So we're going to use the IDPBuilder to do that. So if we go back, and this is part I think haven't not tested, so we'll see the demo gods are in our side.
Let's pray to the demo gods.
Yes. So what we're going to do is I have my Kubernetes manifest files here, manifest base, and let's deploy, instead of base, let's deploy dev. And then dev, we customize very quickly is you can override values from here. So my bad. See here, if I deploy this deployment.yaml, it's going to try to deploy this image. And this image, what's wrong with it? It's not the image that we want, right?
Yep.
And what we can do is put the image, maybe we can have two options. We can do a kind load, right? And load the image.
Okay.
Or we can do a little bit better and make it a little bit more real, because we're not going to be using kind load everywhere. Maybe we can need to build the image and push it to a registry. So we're going to use Git registry to push it.
Git is a container registry as well.
Container registry. So you get also a container registry. So in that case, but I want to leave this one because when I'm running in EKS, it's going to be ECR. So that's why I need to have dev and production. So in dev, I'm going to replace certain things in deployment, in production, another one. So in dev, I'm going to use this URL for the image, git canoe localtest.me. And in production, in EKS, I'm going to use this one. Does that make sense?
It does.
And this is how...
So we can overwrite that.
We can overwrite. Yeah. So Argo CD needs to point to the dev folder in here. So what we can do is, let me see if this will work. I have this Argo CD application.
Okay.
That it will, I'm going to run IDP. Let me explain how it's going to work. I'm going to run Argo IDPBuilder, the create command again, and I'm going to run it in a watch mode. So it continuously runs in the background. I'm going to pass multiple packages. So I'm going to pass a flag that will point to this folder. It will see this file and it will send it to Argo CD, but it has a magic line or a magic string, which is this one, canoe/manifest, which is the repo URL that you want to point to Git. But since dynamically I don't know the address of the Git server, and also I need to move the files over to Git, and I need to create a new Git. So our IDPBuilder will do all these things by just the fact of using
for us. Okay.
So
Okay.
I'm going to point to this folder, and then within this folder, it's going to be the manifest files. So I'm telling it like, hey, grab all the files under this folder, put them in a Git repository, and then the path to use
Will be def, because that's the
and
customization
that'll
that
be
we
the
want to use.
customization
Yeah.
that I need. And let's see what happens. Oh, but we need to push the image, right? Or we can do it before and after. I mean, let's do it after, like to fix the error.
Let's do it afterwards. Yeah.
Make it a little bit more real, right? So if I run IDPBuilder, create again -p, I can point to that folder, which is Kubernetes. Wait, Kubernetes. I don't know what. I'm inside app, right? So maybe I do IDPBuilder create -p / Kubernetes, right? That's better. And then in the side of Kubernetes is where my app.yaml is, my Argo app. Maybe I should call this Argo app.
Okay.
So that's the folder that's going to find it. And then we're going to do -no exit. And then run it. And then we'll see if the magic works. So if we go to git,
we should now see that there is a new repository created.
If I go to git t,
yay,
there's a new repository created. And it has
cool.
base, dev, and prod, and a readme. That's our files
and
in
now,
the folder. So I can go here, and then let's check this out. Since I passed no exits, I can go into. Actually, it created a readme on its own. But I can change anything else in here in dev, right? I can add a label. I can add anything in there. I can add a comment, and it would synchronize any changes that I start doing. So as
you can mess around locally, and it will synchronize to that kind cluster automatically.
Yeah, it's watching, and you can pass -p, -p, so you can have different packages. So it might not be apps. It might be like Cert Manager and Argo Workflows and Istio and like whatever other packages it's watching. But it also did something else. It should have deployed.
And that's what happens through that Canoe manifest thing that we had it, right? Okay.
Yeah. So in this case, it created a new app called Default, and it's saying that it's progressing. So it found, so if I see the details, I should be able to say like that YAML file that we saw. I cannot see it. Manifest.
Oh, yeah.
Here's the manifest, right? This is our manifest, but now repo URL became this Git server, which I knew and I can calculate, but I cannot calculate the name of the repo dynamically because it's going to be called my app manifest, right? And then the dev folder, and it's going to be deployed to a namespace called my app, and it's going to have the option of like, hey, if that namespace doesn't exist, create it. This is good for development, but in production, the platform team would eventually create you a namespace with boundaries, and maybe you don't need the bottom portion. You just need like the namespace. That is going to be always there. But this thing is not progressing.
Yeah. Well, hopefully it's going to be the missing image, right?
Yeah. Here's the error, right? All the Kubernetes events bubble up in Argo CD. So you can use it kind of like a Kubernetes dashboard. So you can see the events. Remember the events? There's no logs, right? Because the app is not even running. And then these are the error messages, right? I don't have an image call like this. What's wrong, Carlos? Like you were giving me this image, but it's not there. So let's go back and let's push it, right? So the way we push it, let's push it to git t. Are you gone?
I am back. My browser crashed.
Oh, okay. Are you still with us?
I am back, but I don't know if my recording will be successful. Let's see.
So for git t, what we need to do is a Docker login, username Well, we need to tag the image.
Yeah,
I
let's tag
guess,
the
right?
image
We have
first, then we need to do a Docker login, what I learned today, and then we need to do a Docker push.
Yeah. So Docker tag, I can do my image, and then I can do this git t, right? And that's the git t. If I try to Docker push, I think I will have an error. Let's see if that's true. Oh, I think I already. Let's see if that worked. I think I logged in before. That's why it worked. So in git t, if I refresh,
we should now see the other image.
No, it's not
the
there.
packages
so
is not there yet.
It lied to us. So we have to
but it said unauthorized. You didn't log in.
Don't know why it didn't throw an error.
It did throw an error.
Let's see.
Unauthorized. Yeah, unauthorized. Yeah.
Oh, unauthorized. Yeah. I don't know how to read.
It's the last line. That's the one that you usually skip.
So git is admin,
yes.
right? And then I need the password, which I need. I think I lost it. So let me open a new thing here. The good thing is we added this command because I asked for it. Get secrets, right? Now I have it here. For git we come back, we put it, we enter, and let's see if we can push.
Yay!
That looks better, right?
Yeah. Okay.
So again, you're now thinking about ahead of me, right? CI/CD, IDPBuilder, the container registry, everything is in a little package. Everything there, and all the workflows can be tested. So this is a shift left for the platform.
This is really good. Yeah.
Super useful to catch this at my laptop, and then potentially in a CI pipeline before we merge anything that would affect hundreds of developers in my org as a platform engineer, right? So if we go back, let's see if we refresh. Oh, I know what's wrong. This is stored in the users, not on the package. Like GitHub also has that concept of like packages at the org level, user packages at the repo level. But here's our repo.
Good.
Here's our hello world.
Cool.
And it has all this stuff.
And it gives us information about our image as well, right? And the possibilities and the information how to pull it and how to access it as well if we want to.
Yep.
That is great. And now the application should be coming up as well, right?
Oh, you're betting on Kubernetes being trying to get us to the desired
You told me that I need to trust on the promises that Kubernetes brings me. So let's see.
So let's see if it's correct or not. So it's still not working for some reason.
Maybe because it stopped after a few tries.
Maybe you're correct. Oh, you might be correct. Let's see if the image is there. Oh, let's sync. See what happens. Oh no, yeah, I think it was a GUI thing.
Okay, yeah, most probably. Now it
GUI
works.
was like thinking that I was like, so the app is up. Still the messages are there, right? But my app is listening on port 8080.
And that means I can now get my hello world as well.
So the thing is, we deploy the deployment, right? Which we're very used to see here, the deployment. But we also deploy a service, which is this one, exposing that port 8080 into port 80. And I like to name my services port. I have my ways. And then I put my ingress, which points to that service, and it just doesn't have to use a number. It uses a port name, HTTP, and I give it a host name, seeing like if any request comes to that Nginx controller that is common across a bunch of apps, and I see this in the header, this host, right? Then I'm going to send it to here. So if we go back to the command line, maybe we do a kget ingress across all of them, and I should see one called my app.
Cool.
There you go.
That means
in the namespace my app, I should see my app running, right? See if it's running. Another useful command is get EP. This is what will tell you if there's endpoints.
Okay.
So there's an endpoint with that port running. So I think I'm feeling like this is going to work. So let's grab this in HTTPS because we are exposing from Nginx the 8443. And then it will even feel like you can potentially configure certificates, right? And make it like valid HTTPS in your laptop.
Okay.
With Let's Encrypt and all those, and Cert Manager.
You forgot the port?
I forgot the port 8443. I just said it, right? And then go in here and this is Hello World.
Yay! Cool. And that is now all running locally, including the Git and enabling us to do GitOps.
Yep.
What would be missing now? So from a developer flow perspective, now if I want to change something in the app, I would need to do a Docker build, Docker push afterwards, right?
Yeah, that's the normal, becomes your normal Kubernetes workflow that everybody's used to. Like make a change to your app, push a new image, like we can do it, right? Instead of hello world, where is my app? Index.js, hello world, and I can say change, right?
Okay.
Right. And then I'll do a Docker build -t, and let's do my image. Well, let's do what we need to do, which is we use the git t, right? See if we can. Oh yeah. So that's the beauty of having AI in your in your terminal, right?
Yeah, it helps you.
So this is 0101, right? We're going to build it, and we're going to push it. Oh, already did it. Nice. I like AI.
Yay.
Push it.
That is way faster now, obviously,
right?
Than before.
And then if we want to deploy, I can test it locally. I can do whatever.
We want to do the change to the Argo CD deployment now, so because we need to change the version to 1.0.1, right?
Yeah. So we go to Kubernetes, we go to dev, we go to deployment, and then we go to one here, save it, and now this should go into git t. Let's see if it went to git t by the time I get there.
No, not yet.
Not yet.
Did you git push it? No.
Running. Let me see. Maybe I'm running too many things. The other one. Let's see. There we go.
Yay.
Maybe it takes a minute.
And now
we're impatient for these type of things.
Yeah.
And then this one, the thing that I was looking this morning was I was telling the team, like, if we can configure git t with a webhook that will send it to Argo CD anytime that there's a change.
Okay.
That's one way of like getting like Git to notify Argo CD. Another way, Argo CD by default waits 3 minutes. We can configure it down maybe to 5 seconds or 10 seconds. In this version, it's 3 minutes. So either you wait or you just click the refresh button. So I click on the refresh. You can see I get a new replica set. This is how Kubernetes works, right? It's a rolling update. It will get the new version up and running before it takes down the other one, so you don't have any downtime in your applications. So let me see.
And then we should have Hello World 2.
Oh, this one is the one like going down. The one that
Yes.
I checked was
Yeah,
this one
the other
was
one is
already up.
already up. So now if
Yeah,
you
it's
reload
up.
that other page, we should
Here you
get the
go.
new
The other
return.
page. Change.
Yay! That
Yep.
was fast. That was really, really fast.
Right. And it's something that if you're not working on this for a couple of days because you're working on your application, right? You may not be like testing to this point. You're not going to be changing this YAML file that often. Like this is once you get them, that's it. For the rest of the week, you should be working on this JavaScript code, right?
Yeah, true.
And then testing with npm start, and then keep testing and keep testing, keep testing. But when it comes to time to do something with Kubernetes, GitOps, YAML files, you just like run one command, and that's it. One command pointing to your folder, this is basically the one command that you have to run.
Cool.
IDPBuilder create -p to the folder, and then we know exit or exit, and then making sure that sanity check, or maybe you can just have a unit, a test script in your laptop that you just run and it does everything automatically in your laptop. You don't even have to you don't have to use your mouse, right?
Cool. Yeah, that's true. So that means now we can just close this all down. And if we then go back to this, we just run IDPBuilder create -p, pointing it to the folder, and then everything kind of will come up as it was before because it reads just local files and there is nothing that is stored in memory. So that's pretty
delete
cool.
all the kind cluster, run this thing, it will create kind from scratch. If you have configuration that comes from your team, that is extra things, right? Your app never runs in a silo like we did today. But hopefully you have -p, and then one thing that we added this week is -p, and you can pass a HTTPS and point to a Git repo where there's files, there's packages that the team is hosting.
Okay.
So they don't have to be in your computer.
Cool.
And then IDPBuilder will git clone that folder, point to it, and deploy anything that is platform based for your app that maybe it's not part of your app. And you don't have to have it in your repo. You don't have to have it locally in your laptop. You just point to it. But the one that you have to have in your laptop is this one. So yeah, that's how you get up and running. I don't know how we're doing with time, or we can do the second section, which is how to get this into ECAS from this Argo CD. Point to an ECAS cluster that I have.
Yeah, I think we should not do that now because we have been straight on for more than 2 hours, Carlos.
Yeah.
So maybe
maybe this is a second episode.
This is a good end point, right? Because it was focused on the local development part.
Yeah, exactly.
And maybe we can get together again to record the part where we now take what we did locally and bring this to an Kubernetes environment that is hosted on EKS or somewhere else.
Yep.
Because at the end, that should be pretty simple and pretty easy as well, right? So
yeah, and then it depends the audience, right? So as a developer, your job is done. Continue working on your AI apps, your business applications, right? On your Java code, your Python script, and your cognitive load. This is how it got there. Let me stop sharing to conclude.
Yay, cool. So Carlos, let's do a brief conclusion.
Yeah.
What did we get? Bring across today? We talked a bit. We started with talking about containers and how do we actually get into Kubernetes and what we need to understand to get there. Because I wanted to understand some magic. I wanted to look at what happens behind the IDPBuilder, and then we later moved into how do we as a developer get Kubernetes locally. And maybe you can just summarize a little bit what IDPBuilder really brings here and what the next steps maybe are for IDPBuilder that you see.
Yeah. So with IDPBuilder, what we're trying to do is give this tool to platform engineers that are, like I mentioned, working with the development team on providing them a internal developer platform. And as you can see here, we don't have to use a dashboard. It's optional, something like Backstage. But to summarize, I want to say that the idea of using Kubernetes as a platform to build software, right? Deliver software is something that it takes a lot of moving parts, both from your local computer to the cloud provider and to the third-party dependencies. And putting them all together, what we're doing in the Canoe project is more than just little scripts and little software. It's showing you how to put them together, like how to integrate all these things together with the latest technologies that have advancement. Like we used to do this, I used to do this like 6 years ago, but the tools were there. Maybe they didn't have the latest capabilities. Maybe they took more time, but we have new capabilities now that maybe people are not aware that they can leverage and fully use automation completely, going from the local system, from the CI system into production. And this is something that is reproducible. Like you mentioned a couple of times, is we cannot just create a platform and configure the system and then test it after it's deployed. We should be shifting left, right? Catch those things beforehand.
Cool. Yeah. And I think that was amazing. Very good details, a lot of good steps on how to get there. And I believe that IDPBuilder and everything that goes around that has a good stake in going even bigger going forward, especially as a lot of people are trying to build internal developer portals as well. Using some of the technologies that are open sourced already today, I believe that it will be very important to be able to quickly iterate on the changes that you do, right? And maybe I have another session in mind that we could think about is at the end, like how to use this setup to now build the backstage extension at the end, right? Because a lot of people are trying to build backstage, and now that's not that easy. Now it gets a little bit easier with the plugin system. Maybe you can also directly use that and test that within the IDPBuilder or within Canoe as a whole.
Right? Yeah, and then we already have companies. You can join the project today. We already have backstage support in it. We have examples of backstage templates, and we have community meetings. This week we showed machine learning and artificial intelligence of like using just in backstage where you click a button and deploy a machine learning that would generate images or prompts and everything from backstage, from using the API directly with like Swagger or Open API GUI. You can call it directly from backstage and also jump into a dashboard that will give you a cost of like how much it's costing you, or from using from Kubectl. So that's all that integration from backstage and launchers. Also UIs is also useful in terms of like using UI extensions or portals.
Cool. So let's link that. I will add that to the show notes as well, so people get the chance to join the community meetups as well. And I will also add the link to the Slack channel for Canoe. So if people want to start asking questions, then they can ask that there. Carlos, thank you so much for this session.
Yeah, no problem.
Great stuff. Really good. I pray that my recording went up, but it looks good. So looking forward to share this with the world and get others to support you on your mission of making local Kubernetes development easier. Yep. Thank you so much, Carlos.
Okay, thank you so much for having me. Bye.